start.
Hello, I'm Mrs. Neill, and this is lesson number 20, Introduction to Trigonometry. Okay, what is trigonometry? Trigonometry is the study of the measure of triangles and of trigonometric functions and their applications. This is just the very beginning of trigonometry. You do trigonometry, a little bit of it, really an intro of it, in geometry class. Then when you go on and take a pre-calculus class, you will study trigonometry again, more in depth though. So in this section that we will be studying in geometry, we're only looking at right triangle trigonometry. Trigonometry uses all kinds of angles, but the only angles that we're going to be using will be a right triangle. So you always know that one of your angles in this triangle is going to be 90 degrees. So let's look at and preview what a right triangle is. So we have triangle ABC is a right triangle with the right angle at C. So we know this angle C is 90 degrees. Remember, side C is always opposite angle C, and this happens to be the hypotenuse. It's always opposite the right angle. We have side A, angle A, and it is opposite side A. And if this is a hypotenuse, and this is going to be a leg. Then you have side B, or angle B, and it's opposite side B. And this is a leg also. And you already know that. So here's a concept we need to learn before we start doing trigonometry. We need to learn what the adjacent leg and the opposite leg is with respect to a given angle. Okay, now, when we do trigonometry, we really don't look at angle C. We don't look at the right angle. We're looking at these two angles when we set up our trigonometric functions. So, let's look at angle A right here. In relation to this angle, which one of these legs is the adjacent leg and which one is the opposite leg? Remember, the word adjacent means it's joined, it's right by each other. So leg B is adjacent to angle A. See, it's actually one of the rays of angle A. All right, what is the opposite leg of angle A? If you notice opposite, I'm looking on the opposite side of the triangle. So the opposite leg of angle A happens to be side A. All right, let's look at what the adjacent leg and the opposite leg is in angle B. It depends on where your angle is, or where you're standing, so to speak. So the adjacent leg is going to be leg A right here. See how this leg is right by angle B. And the opposite leg of angle B is going to be on the other side of the triangle. And it's going to be side B right there, or leg B. So you really need to know what adjacent leg and opposite leg is. So let's look at this again. I'm going to draw another triangle right here. And this is going to be X, Y, Z. Okay, so this is side Y, that's a hypotenuse. This is side X, and this is side Z. So this is a leg, and this is a leg also. Okay, so with respect to X, angle X, what's the adjacent leg? It's going to be Z. What is the opposite leg? Look across. It's kind of like looking on the opposite side of the room. Look across, it's leg X. Okay, in relation to angle Z right here, what is the adjacent leg? Look at the leg that's right by it. It's going to be leg X. And look at the opposite leg. Go across the triangle, and it's going to be leg Z. Now you might ask yourself, if you're given this angle, well, isn't the hypotenuse adjacent right here? It's right by it, but you're not looking at that. You're looking at the adjacent leg and the opposite leg. You're not looking at the hypotenuse in this case. So right now, if we have a trigonometric ratio, it is a ratio of two sides of a right triangle. Now here are our three trig functions that we will learn in this part of the chapter. Sine, you don't call it sin, you call it sine. Cosine, you don't call it cosine, it's cosine. And tangent. Now to abbreviate it, we write S-I-N, but you still say the word sine. It is the length of the opposite of the leg opposite the angle to the length of the hypotenuse of the triangle. If you notice, I have the S, the O, and the H highlighted. So our sine is the opposite over hypotenuse, or S-O-H. S-O-H. Cosine, don't say cos, you want to say cosine, is the length of the leg adjacent to the angle over the length of the hypotenuse. If you notice, I have the C highlighted, the A, and the H. So cosine is adjacent over hypotenuse, or ca. Okay, tangent, don't say tan, you want to say tangent. The tangent of an angle is the length of the leg opposite that angle over the length of the leg adjacent to that angle. So if you notice, I have the T, the O, and the A highlighted. So tangent is opposite over adjacent, or TOA. So this is a little helpful hint. Think about SO, CA, TOA when you set up your trigonometric ratios. All right, let's look at some examples now. So remember, SO, CA, TOA. That means that sine, the ratio, is opposite side over hypotenuse. Ca, which is cosine, is adjacent over hypotenuse. TOA means tangent is equal to opposite over adjacent. So now let's just jump in and start working some problems. Name the trig function used for the given ratio with respect to angle Q. So I'm going to put my finger right here. We're looking at angle Q. So in relation to this angle, we're going to find the sine, the cosine, and the tangent. So if I was looking at P over R, so what is P in relationship to angle Q? That's the adjacent side, isn't it? And what's R? R's the hypotenuse. So which one of my trig functions is A over H? You can either look up here or you can look right here. See, adjacent over hypotenuse is C. So that is going to be a cosine. And you can just write COS. That's fine. Okay, now with respect to Q, I'm going to look at the trig ratio of Q over R. So in relation to this, what is Q? That is the side opposite that angle. So I have O, and then what is R? R is the hypotenuse. So I have O. Okay, which one of these is O? See right here? Or you can look over here. This is opposite over hypotenuse. So this is going to be a sine function, sine ratio. Okay, one more on this one. Angle Q. Okay, what is Q in relationship to Q here? This is the side or the leg opposite. So I'm going to put an O. And then P. P in relation to Q is the adjacent. So I have OA. Okay, which one of these is OA? See right here? It's going to be tangent. Tangent is the opposite leg over the adjacent leg. So I'm just going to write tangent there. All right, now let's look at P. Here's angle P. See, we're not down here anymore. We're up here. So our trig ratios are going to be different because you're over here. You're on this side of the triangle now. So what is P over R? That's going to be opposite over hypotenuse. This is opposite from P. What's O over H? O over H is going to be S. What is S? S is our sine value. So I'm just going to abbreviate it and write that right there. Okay, now in relation to P, what is Q over R? Notice this is the adjacent side over R, which is the hypotenuse. So we have ah. So which one is ah? See right here, C? That's going to be the cosine. And I'm just going to abbreviate it right there. Last one, we're on angle P right here. Okay, here's side Q over side P. What is Q over P right here? Okay, honestly, that should be P over Q. Let me change that. Okay, so P over Q would be opposite over adjacent, and that's O over A. So switch those. Go P over Q right there. And opposite over adjacent would be OA. Opposite over adjacent. So that's TOA, and that's a tangent value right there. Okay. Now what we're going to do is we're going to put some numerical values here. Put some numerical values, and we're going to start right here. This is a very, very basic trig function ratio problem. So where's side P? Remember, it's going to be opposite, and it's equal to 9. Q, that's over here, and that's equal to 12. Uh-oh, I'm missing a side. What's my hypotenuse? How do I find that? You can use Pythagorean theorem. Remember, I can go a squared plus b squared equals c squared. Equals actually r squared in this case. But if I know my Pythag triples, which you should be memorizing those now, this is a 9, 12, what? 15 triangle. So instead of using Pythagorean theorem, if I know my triples, I found 15 very quickly. So right here with that information, let's find the cosine of angle Q. Here's angle Q. What is cosine? Cosine is that's adjacent over hypotenuse. So in angle Q, where's my adjacent side? That's going to be 9. And then the hypotenuse is 15. So what is going to be 9 over 15? Let's see. Let's reduce that by 3. And I get 3/5. So see my trig ratio? It's a ratio of two sides of a right triangle. But you want to reduce it like you would any fraction. Okay, let's take P. What's the cosine of P? Cosine is ca. It's going to be the adjacent side over the hypotenuse. Adjacent side is 12. Hypotenuse is 15. But I want to reduce that because I like to reduce my fractions. Let's reduce that by how much? 3. And that will get us 4/5. Okay, don't forget to reduce that. Sine of P. Okay, here's P right here. I have my thumb there. What is sine? It's O. It's going to be opposite over hypotenuse. So what's the opposite side from angle P, which is 9, over the hypotenuse, which is 15? Reduce that by 3. And I'm going to get 3/5. And I'm going to box my final answer. Okay, how about the tangent of P? Okay, what is tangent? Okay, tangent is TOA, which is opposite over adjacent. So tangent, I'm going to write opposite over adjacent. So in relation to P, what's the opposite side? That's 9. And what's the adjacent side? 12. So what is 9 over 12? Let's reduce that by 3 and get 3/4. Alrighty. Let's do one more. The tangent of Q right here. Tangent of Q. So in relation to tangent, what is tangent? You need to know your SOHCAHTOA. Okay, tangent is TOA. It's the opposite side over the adjacent side. So tangent is going to be opposite over adjacent. So in relation to Q, what is my opposite side? It's going to be 12. And then what's my adjacent side? It's going to be 9. 12 over 9. I can reduce that by 3 and get 4/3. Okay, this is our very, very last problem. Sine of Q. Okay, I want this angle right here. So in relation to this angle, what is the sine? What is the ratio of the two sides of that right triangle? Remember, SOHCAHTOA. Sine is the opposite side over the hypotenuse. So sine is going to be the opposite side. Oh, let me go ahead and write opposite over hypotenuse there. So it's going to be the opposite side of 12 over the hypotenuse of 15. Let's see, we're going to reduce that by 3 and get, by 3 would be a 4. 4/5, not 3/5, but 4/5 right there. So the answer to that very last one is 4/5. All right, that is our basic lesson on trigonometric ratios. I'm Mrs. Neill. Thank you for listening.